Hello, everyone. Aaron and Johnny.
Hello.
We're back with you for the comparison of a single link stack and a array resizing stack. And yeah, this was annoying.
It was, but we got it, and we're here to help you get it before it's due.
Yeah, for the last probably 2-3 hours that this will be up for. A couple things before we get started. First off, I do want to make mention. I did threesome according more based on what he did in class in comparison to what it says online. So my function or my program doesn't actually go through and calculate the run times of it itself, or the ratio of it itself. It gives me the runtime, and I calculate that in the Excel spreadsheet. It says online though that you should do it. That you should have the program do it itself.
Yeah.
But
So we did that for this one, and I think you're planning on going back and redoing.
yes, I'm planning on going back and redoing it. I don't know if I'll be able to get that done tonight. I'm gonna try. It'll be up whenever I get it up.
Based off of how many people I'm assuming did it the way that we did it with the doing it wrong at first, I don't think he'll be too harsh on that.
Especially because, like, you have to have the book with you, and
It's free online if you want to find the textbook online. But
yeah.
me and Zach followed through the textbook, and that made it a little bit easier to make it work the way that it seemed like he wanted it in the description as opposed to how he explained it through class.
Yeah, because, yeah.
So our two files here.
Another warning before we get started.
Go ahead.
I am on my 6th cup of coffee, possibly starting a 7th soon. So
Don't do it, Aaron.
I'm going to need it. But anyways, so, yeah, fair warning. All right, now we can get into
So our
this.
two different files we have are I can't read your screen that well. Doubling-ratio.java and doubling-ratio2.java. So the first one is the one comparing the singly linked stack, which the class singly linked stack that you can see there, which you can open real quick, Aaron, that is directly copied from our infix to postfix. Nothing different at all. So we're not even going to go over that. We have a video on infix to postfix if you didn't get that one working. If that's the case, it'll probably be a while. Good luck. I'm sorry. But that is directly copied from infix to postfix. Our class stopwatch is found in both files and is simply a way of doing a timer. There's multiple different methods of doing timers. If you did something using a different method, by all means, continue doing it the way you did it. This way might not be the easiest. This is just what was recommended in the textbook.
If you actually did what I did in the last episode with threesome, where I just had the time as a variable, that's pretty much what they're doing here. The biggest difference here is that they are doing it A in a function that's callable in their own class, and B, they're converting it from milliseconds to seconds. So whenever you see our output data, it'll be a little bit different. But
Yeah, it'll be outputted in how many seconds passed.
As different from I need
So
more coffee.
I'll go over this real quick. We got private long start in the class stopwatch, which I'm assuming is the constructor. You're just simply setting that long variable to the current time on the clock when that function is called. And the other function we've got here, public double elapsed time, takes the time now and then returns the time now minus the time at the start that you got earlier, and then divides to convert it to seconds.
Yeah. This is probably a good idea of just making into a class as well if you're going to be running with a lot bigger numbers, as we will be later on in this, just because it will take seconds more like for those bigger numbers. So this is probably not a bad idea to just go ahead and implement and have in your back pocket. Something
So if you want to go ahead and open up doubling ratio, the nice thing about the two different files is that doubling ratio and doubling ratio 2, the classes are both very, very similar. There's just a few differences in how the time trial functions, and that's pretty much it. I think the main is exactly the same, so I'll go through that real quick, because the main is more of the outer loop, and then it calls and goes to the time trial. So in the main, we have a old time, which we set to 1, because if you set it to 0, you get some divide by 0 errors initially. And then we have our main for loop. I set the initial value to very large because if you start somewhere lower, you can, but you get a lot more inconsistency, and each trial is done really, really fast. So we figured we'd just start where it starts getting a little bit more complicated and more useful results, which was around 100,000, I believe.
Yeah.
And it just goes through that forever. That's why that second thing is true. And then you're multiplying by n instead of n plus plus. Or, well, not multiplying. You're adding n to itself, which is doubling it every time you go through.
The reason why whenever we choose to double it, that instead of doing n times equal to, we're using n plus equals n. The reason why we decided to do that is, well, inadvertently decided to do it, I think.
Yeah.
I don't think you guys really thought about this, but at least an intro to comp sci, because that's where I'm at right now. We're talking about how multiplication does take a longer time to run than it does addition.
Yeah.
So that's just going to cut down on our runtime, and we're going to be able to focus more in on our runtime for, like, it'll just make everything a little bit more cleaner, a little bit more
It's a
faster,
little bit faster. Yeah.
which is important whenever you're dealing with these super big numbers.
So inside this for loop that will be going and doubling each time. So we have our value time, which is going to be returned from the function time trial n, which we'll go over in just a minute. But that's simply returning the amount of time that it took to run that current trial. And then what it does is it goes through and it prints what trial it was on, which is n. It prints the time, which is how long it took. And then it took the time divided by the old time. Now, why did we multiply both the top and the bottom by 10,000 or 100,000, whatever that is? I can't see how many zeros there are right now.
That is 10,000.
The only reason we did that is because if you didn't, sometimes it would round the answer for old time or new time to 0 if done very quickly, and it would have NaN error or infinity error. So multiplying by a big number on the top and the bottom, it cancels out, but the way it does the arithmetic, it actually does multiply and then make a big number divided by big number, which will not give you infinity or 0.
And then the last line is setting old time equal to the time that we got in this run. And when the same way kind of as in the last video whenever we dealt with the Excel spreadsheet, it's basically taking that time from one cell left up. So
let's look at the time trial for this one.
no, let's just not give it to them.
That would be mean. We're trying to help them.
Yes, we are.
So this one is the one, again, with the singly linked stack. So we're creating a random variable name A, but it's a singly linked stack of the type integer. Unfortunately, we figured out that you can't do a singly linked stack or any generic item type with a data type, which is base. So you can do a string, you can do integer, but you can't do a float, you can't do a double, you can't do an int. You can't use the base data types. You have to use a slightly more complicated or higher level object, which is why we chose to do integer, because it's simple to use. You could easily do this exact same thing using strings, and your time would end up being similar, or at least the ratios would be. And then what we do here is create the stopwatch, which is just how you start the timer, basically. And then we go into the for loop. We'll get into what the for loop does in just a quick moment. Where is push? Where did push go?
Right there. Line 9.
No, I'm saying where is the function for it? Did you not copy that one over? That one's in ratio 2, I think.
No, that one's in single linked list. So the push that we're referring to in this, we gave singly linked stacked the.
I forgot that that's the thing in this stack.
Yeah, we gave this.
I'm
someone
tired.
needs another cup of coffee. So we gave it this, the letter A for our object. So we're doing a dot push is going to be I.
You can push anything you want.
This this one, it would probably be better just to put push I, because we're not actually going to be computing with this. We just want to test the actual runtime of it.
Yeah, all we're testing is making the stack and filling it as quickly as possible. Yeah. So it doesn't matter what we're filling it with.
So if you're wondering where the push for this one is coming from, that's coming from this line down here, public void push item thing,
Yeah.
which is very, very specific.
Yes.
Item thing. But
Item thing.
then we go through and we do timer dot elapsed time.
Which is what ends the time and then returns it in seconds, which then in the main is what we are returned and then we print out.
Yeah, so that goes in there.
And that, so let's talk about now the other file, which would be the one for the array resizing. So if you look at the main, let's look at the main real quick.
Okay.
So close push and close time trial.
Yeah, right there.
We'll get to them in a second. Main is very similar. In fact, I believe it is the same.
It is exactly the same.
Yeah.
And the good thing about this is because it's exactly the same, this is a block of code that you can copy and paste from your doubling ratio. So it was very smartly designed.
Yeah. So go ahead and look at the time trial, which is similar. Now we have A. If you actually look before that, look up at the top above the public static double time trial. We have globally defined a integer array. Now here we could do an int array, which would make it be faster, but for the sake of consistency between the two files, we wanted to do an integer instead of an int because we were doing integers with the linked list, so we do an integer array instead of int array. And then we also have a integer, an actual int, keeping track of where the tail is, which is the top of the stack.
Yeah. So after that, we're going to go ahead and get into our time trial because, as we said, stopwatch is pretty much the same.
Exactly the same.
And we'll get to push whenever we actually get there.
Yeah.
That sounded very weird. But basically, we're going to take A, and we're going to give it the new integer 1.
Yeah. And you have to do this a second time inside of the time trial because every time you loop through it, you need to reset it to a empty base array and reset the tail to 0.
Because since it is that global, whenever we go through and make changes in it the first time, those changes are saved because it's a global thing. And we're not doing what I did in the previous threesome, which is going in after each run and changing the index like hard coding.
The reason we made it global is so it can be accessed and modified in both the public static double trial time and also push, which we'll get to in a moment. So it starts the timer right there, and then says for the going through the for loop, I is less than n, I plus plus, I starts at 0, and we're pushing I.
So we'll go ahead and look at push now because
and then after it does all that, it goes through and returns the time in seconds to the main, prints it out. So pretty sufficient with what's going on there.
It's almost exactly the same again, but
It looks very similar. It's just push functions differently.
So, I don't know if this is exactly what you did because I kind of built this myself, and I don't know if we've actually looked at each other's computations.
Okay, that's
but,
fine.
So basically, if our tail length is a.length minus 1, which basically all that's checking is, okay, if I'm about to run out of room, I need to go ahead and increase the amount of, I guess, spaces, if you want to say, indexes in my array. So it's going to create a temporary array.
So if that's basically saying if it's full.
Yeah, if it's full. So we're going to do a new integer array because we still have to be using that object.
And you're doubling the size of it.
Times by 2. And then this is just the for loop that's going to say, okay, for that length, we're going to copy it over completely.
This is exactly what I did. Yeah.
Yeah, okay.
Yeah.
And then
You go through, copy it over, and then set A equal to that temp.
yeah. And then once you're out of that if, which means, okay, whether or not you had to double it or not, you're still going to do this. You're going to increase tail by 1, which tail is the index. I don't know if we actually covered that.
Yeah.
Tail is not the actual value, it's the index that we're looking at.
The index of the top of the stack.
So, and then we're going to do A at tail is equal to Fido, which Fido is the variable that we're pushing. Throwback to
Crawley.
Throwback to Crawley.
Okay,
That's miss him.
About it, and we're trying to keep it quick to help you guys and be as concise as possible.
Yeah.
Again, any questions that you have? Oh, one thing I wanted to recommend is you might wonder how you want to submit this to him. On Canvas, I would recommend, based off of what it's saying in the description of the actual assignment, you want to submit both of these Java files as well as a sample of the run for each of them. But here's an example of what our run looks like. It tells you on the left column that actual number, the middle column is the time, and then the column is your ratio.
Which is t of 2n over t of n. And remember, this is different from our actual. This is going to be counting by seconds, that middle row.
So if you redo threesum to work the same, the ratio for threesum comes out to be somewhere averaging near and near towards 8. And in both cases here, it appears to be averaging towards 2.
So, yeah, that's pretty much what it's going to be. And this will run pretty much an infinite amount of time because we did something very, very bad and had a always looping an infinite loop. So this will kill itself eventually.
Or it will run into a
Java
place. Well, if it
error?
makes an array too big.
Yeah.
For the array one. The one that is the singly linked list will just keep going until you
Yeah.
it gives up on life.
So we're going to go ahead and leave this here. If you have any questions, feel free to email us.
We'll try to get back to you tonight before it's due.
I will be taking a break, and I don't know if this will be up in time, but I will be planning on going to Wednesday Night We Eat to take like a 5 or 10 minute break. So if you want to try and catch me there, you can, but I don't know if this will be uploaded in time.
Probably not.
Probably not, but oh well. So, yes, thank you everyone so much for watching.
Have a wonderful night.
Have a wonderful night. Don't overdose on caffeine like I probably will.
War programming. Ratios of the time for the one where you do the same thing but using a resizing array.
And before we get any farther into this, I have 2 things that I would like to say. First off, once we complete this video, I'm going to be going back and rewriting my threesome.
We have to change the image
For what one?
doubling ratio 2 and probably doubling ratio 1.
What's wrong with them?
Doubling ratio 1 is fine. Doubling ratio 2, we need to make the int array a new array. You just have to do this.